Hello student, here we discuss about the classification of structural isomerism. Now you know what is the structural isomerism. The compounds having same molecular formula but differ in the structure. In where the structure, how the structure is different, again on that basis the structural isomerism is subdivided into following types like chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, a ring chain isomerism, and several types. So here we will discuss one by one. Now first we'll discuss about the chain isomerism. Chain means the compounds having the same molecular formula but they are different in the chain. So there is a straight chain, branch chain. Okay, so we'll take example of the pentane. So CH3, CH2, 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 and this is CH3. This is we called as N-pentane, and we can write its isomer. matlab you can see it here how you can write. So I will take this side. Okay, so this is again, it is a normal straight chain. Here is the branch. In branch it is we called as, this is isopentane. Both are having the same molecular formula, CH3, CH, CH3, CH2, and CH3. So both they are having the molecular formula for these two compound is molecular formula is equals to C5 and H12. So 1, 2, 3, 4, 5 and 12 is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the molecular formula for pentane. So it shows the isomer. Can we write one more isomer of this one? Yes, we can write it. So these are the four possible isomers, and this one we called as the neopentane. These are all the common name system. So here is methyl group, here is methyl group, here is methyl group, here is methyl group. So this is nothing but these are the isomers. Both, all of these, they are having the molecular formula same but their structures are different. In what way they are different? Their chain is different. Here is the straight chain, here is a branch chain we call as isopentane, and here is again the branch chain, it is called as the neopentane. So we can, so if in exam they will ask write the possible isomers of the butane. So in butane, you know, there are 4 carbon atoms are present, and then we can convert this butane into this. So can we have the neo here? No, no neo. Okay, there's 2 isomers only. So in this way we can talk about the chain isomerism. Now the next is the positional isomerism. Positional isomerism. Now position means the compounds having the same molecular formula but the position of functional group, position of alkyl substituents are different. So that's why they are also called as the positional isomerism. For that I can take examples of the aldehydes, ketone, alcohol, alkenes. I can take alkene as an example. Suppose here you can see. So I can take this C, C, C and C. So it is a butane. So I will put one double bond here. Okay, so this is butene, and I can write it's one isomer. I will change the position of double bond, C, C, and double bond is here and C. So these are the 2 examples. Now look at here, double bond is present here, double bond is present here. To understand this example, we can number this carbon. So here is 1, 2, 3 and 4. Here is 1, 2, 3 and 4. Now look at here, in this case the double bond is present between the carbon number 2 and carbon number 3, but here the double bond is present between carbon number 1 and 2. So we can attach this hydrogen atoms to it. How it looks like, this is cs3, ch, and cs3. This is ch2 because carbon is having valency 4, so we can write this way. So this is what is the name of this compound. I can write here 1 butene because double bond is present at carbon number 1, and here we can write 2 butene, है ना, 1 butene and 2 butene. So these are the isomers. They are having same molecular formula, but they are having molecular formula is what? That is, I can write C4 and H8 because 2, 3, 4, 5, 6, 7, 8. C4H8 is the molecular formula, but they are differ into the structures, and that's why it is called as the position of double bond. They are different, so it's called as positional isomerism. Now the next example I can take it, I can take the example of alcohol. Okay, that is, alcohol is nothing but I can write CH3, CH2, CH2, and OH. This is 1 propanol. I can write its isomer. Okay, this is propane. I can shift this position up to here. So it is CH3, CH, and this CH3. This is 2 propanol. Okay, so what is the difference here? You can see, student, the hydroxyl group is present at carbon number 1, and in this case this hydroxyl group is present on carbon number 2. So the position of functional group is differ, and that's why this isomerism is called as the positional isomerism. There are several other organic compound, they also shows the positional isomerism. I can take one example of again the ketone. See the CS3, CH2, C double bond O, and CS3. Okay, I can take one more CH2 here and CS3. Now you can see it here in this compound, the what is the difference. I can write it's one isomer, CH3, C double bond O, CH2, CH2, and CH3. Okay, this is also the difference, and you can see it here. There is a carbonyl group present, 1, 2, 3, 4, and 5, but here this carbonyl group is present at carbon number 2, and that's why there are several examples we can take it. The position of the functional group is different. Again, this comes into the metamerism also. These are aldehydes and ketones. These are the isomerism.